All right, so last time we looked at this project, we had some issues that were going on with it. It was getting stuck in these loops, and I mean, that was really the big thing. And so I'm here to say that I have changed my training parameters a little bit. I've changed the scenario a little bit to make it, I think, more amenable to the training that I'm trying to do. And it seems to be working pretty well. It still gets caught in those loops. I think it's an issue with local minima, but I actually figured out how to get around that, so I'm going to show all of that off. So first thing I'm going to go over, I'm going to talk about how I changed the environment. So now, instead of a set time where you were trying to collect as many points as you could from a given start point, basically I made the entire scenario you're trying to collect 1 point. The other thing that I did is that the hand starts at a random orientation, right? And I did this just to make sure that we got a little more coverage. I thought it might help get some more of those edge cases. So we start here at a random orientation, and then we're off to the races as we're trying to collect things. You'll see we do end up in cases where we hit local minima, and it wasn't really clear what was going on until I slowed this thing down a little bit because we're super fast. Right, so now I'll slow it down here, and we can start to get a better sense of what's going on. It's not really facing the ball, it's facing this other way, and it keeps going in the cycle, and that's actually pretty important. If I click on one of these arms, right, we'll see that it keeps flashing between this desired bend and current bend. And they're kind of stuck in the same way, and then this desired bend, it's cyclic, right? So that was really interesting. So I was hoping to get rid of more of that by starting it in a random position, having the target in a random position. I also moved the targets out a little more. I did find, I think, one case where I wasn't able to reach the target with the previous distances. So now the distance shell is 1 meter to 2 meters instead of 0.5 meters to 1 meter. So I opened the space. Well, I guess I don't know if "opened" is the right word, but yeah. So I changed the kind of the shell size that the target can appear in from 1.5 meters thick to just 1 meter thick. The other thing is, because we're trying to just reach the target once, I also put a time component, so we can see here in my agent, every step I subtract 2/1000ths of a point. And so the idea is that we still want this to get to the target as quickly as possible. So here is my tensor board for the training on this modified simulation where it starts randomly, only tries to get 1 point, and then receives a per step penalty. This, I'm going to turn off smoothing so you can see. This is by far, I think, the single most beautiful and explanatory cumulative reward curve I have ever seen. It doesn't really get better than this. I have smoothing off, and you can see how this thing is completely asymptotic, right? It does take some time to get to the point. Maximum score would be 1 as if you instantly got the ball. It does take some time to move the arm to the ball and get it. And so you can say that 0.9 is about as good as this is ever going to get. But it's not doing these crazy flopping back and forth, right? So I took the problem, boiled it down, made it real simple. Random start, random target. Put a little bit of a time penalty on there, and so, just get to that target as quickly as you can. Now, I did see a little bit of interesting behavior because it will tend to flop the arm about more because it covers more distance in a given point of time, and there's no penalty for movement. So we can also look at adding a, again, very small movement penalty. You don't want your movement penalty to be too big because you want that to be an optimization, but it would be easy to have your movement penalty drown out your reward function, and then you're not able to actually get anything done because it's so afraid of moving that it won't do anything. So this cumulative reward curve is beautiful, and it got very close to the asymptote at like 4 million. There's really no difference between 4 and 5 million. you know, really 3 million is still pretty darn good, but yeah, a 5 million training run, and we are clearly there. We're absolutely there. So again, the downside of this is that we still get caught in these loops. Now, what I think is going on is because it is every frame, it is evaluating its current position and where the ball is. And so what's happening, yes, this is a great example of it, is that we're getting caught in these local minima. And so by slowing this down, it just makes it really, really easy to see that we're in these little cycles. And so I figured out a way to do this. When I was playing with the Simple Robot Academy, I have this frame to skip variable. And so basically that says is you don't get to evaluate every frame. Now, when I do the frame to skip, what happens is sometimes it'll get caught in a different loop. So what's happening here, as I've said, I'm skipping every 2 frames, right? And by skipping every 2 frames, it is not constantly telling the arm change, 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 change. It takes a couple steps to actually move, and so this actually makes the cycles bigger. In some cases, this solved the cycles. In other cases, it didn't. But what was interesting is it made the cycles bigger or smaller. And so I was playing around with this, and I realized that because we're in these cycles, one of the things you can do to kind of break out of the cycle is change this frame to skip number, and hopefully you'll get into a different position in the cycle. And by changing it in random places, you can actually, boom, get out. Oops, I changed it to 13. You can get out of those cycles, and so you get out of this loop where you're constantly evaluating and finding this local minimum, right? Or actually, it's a series of local maxima that are all feeding each other. So unfortunately, changing this in here isn't really tenable long term for anything, right? So what I have done is in my agent down here, I have some step skip randomization, right? And so from 0 to 4, right, I will just have it skip a random amount. And I will change these up a little bit again. And I think 180 is where I was pretty happy. Yep. There we go. So 180 degrees a second is really moving along. And so what's happening here is that with some randomization, I am randomly changing how many frames I skip. And by doing that, I'm forcing it out of these loops. And by doing that, I have yet to see it get caught in one of these eternal loops. So it's a bit of a hack. You know, we haven't smoothed out the formula so that there are none of these local maxima loops, and then it doesn't get to the global maxima, which is getting the reward. However, what's really cool about this is it is a very practical way to go ahead and solve some of these behaviors, because, you know, in this case, I'm only skipping a couple of frames. It's acting, you know, we're calculating 30 frames a second. So it's happening so fast anyway, it doesn't really need to be calculating every frame. But by mixing up which frames it's calculating on, it isn't getting trapped in those loops for long periods of time. And it's doing exactly what I was hoping that it would do. Now, the other thing that's interesting going on here, again, we mentioned this a little bit, is that it's waving back and forth, right? It's doing this herky-jerky motion because there is no reason for it not to. The more space it can cover in a shorter time, the higher likelihood that it will hit the target, maybe by accident. But what that means is that because there is no cost to moving, it is more likely to move more. So we'll have to look at adding a cost variable that anytime that it moves, we subtract a very small amount. So I think where I'm going to put that is in the actual bend functions. We're already providing it the current angle for each of the arms. Ooh, did we actually get stuck? Did we get truly stuck once? I don't know. I mean, it's been going for a while here. Yeah, it looks like it might have actually gotten legitimately stuck. Huh, look at that. Certainly way better than it was. So maybe not quite perfect. Definitely want to do some more testing. There we go. The skip max, probably don't want it as high as 10 because skipping 10 frames, that's a third of a second. Might be a little much, but we'll try 5. But again, messing with that variable, and there might be a distribution that I come up with so that it never ever gets stuck. Because by being able to adjust those parameters, I have not gotten to the point where it is unfixable, which I think is really good. So next thing, I want to make it more efficient. So in my bend functions here, yes, no, no, it is going to be in not the agent, not the academy, not the manager. There's the controller. Yes, so here we have our delta. And so this delta is the amount that I'm moving in a given step. So I think I am going to associate that delta with a penalty. Again, a very small penalty, because more than anything, I want it to get to the ball. I would like it to get to the ball as efficiently as possible. But at the very least, I want it to get to the ball. So that's where we are. It's working great. I'm thrilled with how well this is going. And again, we're doing a full reset every time. So I would just need to change the parameters of this because it's now used to starting from a random location. I can also change the parameters so that this becomes a continuous thing. That we're not resetting every single time completely, that we're just moving the target around, or that we can start integrating this in with other tools. So I can't wait to show you some of the things that I'm hoping to do with this. And part of me is saying, man, now I really need a robot. I have some Lego Mindstorms, so maybe I'll use that and see if I can come up with a rudimentary robot and see if I can communicate with it and mirror some of the speeds and attributes of that robot, because this is extraordinarily encouraging. So any questions, shoot them my way. But this is, I think, absolutely good enough to be used. Certainly in entertainment stuff, it has that kind of herky-jerky, non-human behavior that I was hoping for. I didn't want it to look superhuman, and it certainly doesn't. So it's doing really what I hoped for. And then again, we're going to see if we can put together a real robot arm and control a real robot arm with this code, or something very similar to it. So very exciting, huge progress. Absolutely thrilled to be able to show it. Oh, and you can see that it's stuck in a loop, or that it's not quite there, but it's working its way out, right? You can see these loops a little bit, and then it self-corrects, and boom, it got it. So it's not perfect, but gosh darn it, I am thrilled. So, yeah, because this thing's working. It's just doing the job over and over and over again. All right, any questions, whatever, leave them in the comments. I'm going to keep working on this project for a bit, because there are some other things that I'd like to do. But I think this is, I'm super thrilled to have made this kind of progress. So thanks for watching, and can't wait to show you what I'm up to next. Bye bye.